And it's all yours, sir. Take it away, Pedro.
Okay, hello folks, welcome to PulpCon'. My name is Pedro. I work at the Pulp project for like 2 years, and I'll talk a bit about the tasking system in general and some updates we had this year. Uh, Oops. First, thanks for the tasking working group, Dennis, Brian, Deco, and Matthias. We formed this work group to work on those stuff on the bulk tasking system, and it's all the work I'm going to show here. Special thanks for Matthias for mentoring me in the tasking system and in various conference topics. To provide an idea of what we'll cover, first I'll give some background on the system more in general and give some history. Then I'll show some technical details on how the system worked before the changes. Then I'll talk about new requirements from Pulp services and some developments we made on top of that. Finally, we'll say some brief final words. I'll open for questions at the end of each section because they are a bit dense. So let's get started. In general, I hope you have a good idea about what Pulp is, but let's go real quick through this. Pulp is an application that manages software packages like Python, RPMs, Deb, whatever. And I want to just highlight that if your organization needs this kind of service, you can do two things to get content there. You can upload, or you can perform sync operation, which gets content from an external repository. These are two base operations you can do with Pulp and are relevant to this talk. And also you have clients. For example, for Python, you have pip or UV. For RPM, you have PNF. And you can configure them to talk to Pulp. That's enough, I think, for getting started. So that's it. Pulp can serve content. Pulp can to clients. Pulp can sync content from remotes. Pulp can upload, process uploaded files, and all these operations are related, can be related to tasks, can trigger tasks. Here's a brief overview of Pulp's architecture. There are three components. A serve request will go here, like if pip wants to get some content. A general operation like sync or upload will go to the API. And the worker does not talk to the outside world. You can see here some transitive communication using the database. And that's a very important thing to keep in mind about the inter-app communication. And it's also important to understand why we need it in the first place. So let's see. The brief example of the previous slide, we've seen a little about syncing, which is an operation that can take quite some time. In general, we don't want to block the API for something that can last like hours or something. I'm saying in general because that's not always the case. We might have some talks on this PulpCon about it, but let's move on. Pulp serializes tasks that are unsafe to run in parallel. This is a very important point and a key to the current tasking system design. By unsafe, I mean if two processes try to read and write concurrently on some resource, they could deadlock or have some unpredictable results, like what would happen if a remote URL changed in the middle of a sync. I don't know, but I don't want to find out. And since we want to discuss changes, let's go quickly through the tasking system timeline, which I think looks like this. I've never met these two men in my life, but when I joined the team, we were on vanilla tasking system already. But I've heard some stories, and the stories were that RQ had a problem with resource management. It was bottleneck for scalability, and also there are some problems with data duplication because RQ uses Redis and there are data on Redis and Postgres. So there was a system that came out in 2021, and it solved those problems with distributed task pooling, which means that each worker tries to pull tasks independently. Here, while the previous system was relying on this bottleneck here. And you can get a feeling how each worker having independent improves horizontal scaling. And the duplication problem is solved because there is no reliance on Redis anymore. Also, it was introduced the PG advisory logs for handling resource locking. We'll see that in the next section. I won't talk much about the results, but there are some great improvements in service time, and I'll put a link to a blog post from Matthias, which explains some of these results. Great, we've reached the end of the first part. So we've learned what PulpCon is and about architecture and operations, some motivations for the tasking system, and some improvements from past iterations. Now stop a bit to drink some water, and if someone has questions. Okay.
Maybe just one remark. Your characterization of this is how I imagine the old tasking system worked is quite good.
Oh, great.
To be fair, the problem was not primarily RQ itself. The problem was that the specific edge cases or the specific idea about how to serialize tasks that Pulp imposed on the tasking system led to this tasks being saved into databases. And that somehow we never managed to get consistent. So I want to get just make clear that we don't blame RQ for being bad. Just it's the wrong tool, or it has been the wrong tool.
Yeah, thanks for clarifying that.
Thank you.
As I said, I wasn't there, and I really appreciate your feedback. So let's. Oh, great! We have another question. Alexis.
Yeah. So I wanted to ask, what is the decision making between, how do we decide which operations require tasks and which do not?
Yeah, that's a good question. Operations that are long running require tasks. Operations that operate on a specific resource, such as a repository, also require tasks. And so to give more concrete examples, whenever a user requests that a repository is synced from a remote, that will be a long-running operation that needs to be done asynchronously so that the web server handling the initial web request doesn't time out during that time. We also want to make sure that tasks for specific resources like a repository are performed in the order that they were received. for example, once you ask Pulp to perform a sync of an operation, and then you ask it to create a publication of that repository, we want to make sure that the sync occurs first and then the publication occurs, and that the publication doesn't occur in parallel with the sync, so that the user gets the expected results. Because if the publication occurs before the sync finishes, it's going to publish the repository version that was there before the sync had finished. There are some shorter running operations that also end up getting performed as tasks. And that is also to ensure that they occur in the order that they were received. And I can't right now think of the exact short running or like immediate tasks that we do.
Update repositories, update remotes.
Yeah.
update
Okay. Thank you,
Right.
Pedro.
The
Yeah,
URL
yeah.
or something like that.
Yeah. Does that answer your question, Alex?
Yeah, so if I understood correctly, one case is basically when the operation can be just long enough.
Yep.
And the second one is when we have to ensure some, what it's called,
Order of operations.
order of operations, and do not allow two writes at the same time, basically, right?
Yeah, something like
Exactly.
that. Yeah.
Got it. Thank you.
Yeah, good question.
Yeah, good question and great explanation. Thanks. And I'll read out loud Daniel's comment, which is also important. Another motivation is for security or latency reasons. You might want to avoid it on the web server. There, fair point. So I'll get going. See, I'll share this slide after the presentation. I put some links there. And let's see some internals now. These are the main components of the testing system. We have this role I call dispatcher, but because all of the three components of Pulp can dispatch tasks, even workers themselves dispatch tasks, because we have scheduled tasks that the worker dispatches and kind of itself in sequence. We have the worker. I put here this to illustrate that it creates a child process to handle the tasks themselves, like in isolation, that kind of can prevent memory leaks. And the design we choose. And have Postgres and some important models like tasks and app status. App status is like the record that represents a Pulp component, the API content or a worker, and it's where the heartbeats of those components is saved, so we know they are alive or not. Now, if you look at the worker typical life, we observe something. It has a heartbeat going on. Let's say when it goes up, it's a heartbeat. It will save database. And it performs what I call janitorial work at a regular heartbeat cadence. There are things like cleaning up stale records or doing metrics, which doesn't have to happen too often, but can't be too long too. So then there's this informal state here. A worker can be sleeping, so it won't be doing too much apart from heart beating and janitorial and some other stuff. But or it can be working, and the work is basically unblocked tasks I'll talk about it later. Cleans tail tasks, try to acquire a task, and if it succeeds, start supervising that task. Task representation is also key to the system. Let's look at some fields. Name is a valid Python identifier for the actual function that the task will run. So a sync task will have the module, the file, and the function name where the sync function is located. We'll see more about task states in the next slide. Reserved resources records are the resources the task needs, which is important for unblocking algorithm. And when the unblocking algorithm determines a task requires a resource, a task required resources are not being used, it marks this unblocked at timestamp. So the task can be picked by a worker. It's assured that it won't have conflicts. Finally, there's this immediate flag, which Dennis talked a bit. It's about those short tasks. Here's a state machine of the task. The canceling can be reached by either waiting or running, because a user can request cancellation before the task is picked by a worker, or it can be running when the users request the cancellation. Then if it's running, it can succeed or fail. And there is these two states here because you can just cancel the task and it's done. You have to do some tear down operations. Locks. So this is a simple mutex supported by Postgres. In general, before a work starts doing some work, it will try to acquire the lock for it. Then after doing the work, it will release. Locks are not only used for tasks. They are used for other activity, such as unblocking tasks or dispatching scheduled tasks. I think when people think about locking, they usually think about the task or source locking. There are other stuff too. And these assure the serialization we've talked about. Only one worker can do this thing at a time. And this is a specific thing about the session-based advisory locks, because a worker can die unexpectedly. But the session-based advisory locks is something that's held on the Postgres process. So the connection is dropped for some reason, Postgres can release it. It's on your side. Finally, bulk levers, the Postgres list identifies signals. That's before the changes. For example, a dispatcher may dispatch a task, which means a new task is on the waiting state. It will usually send a notify to Postgres, and Postgres will send it to the workers so they can wake up and unblock those tasks and make them available for picking. Cancellation also uses this kind of broadcast mechanism. Here's a bit how we handle those signals we receive. Okay, let's do some recap here. We did an overview of tasking system components. We've seen a bit about workers, tasks, and some different locks, and a basic understanding of the signaling mechanism.
Pedro, I'm gonna
again. Yes, the time. I know.
Yeah, I was gonna try. I'm just gonna push you ahead. Now we've got technically 5 minutes. You can go 9.5 more, but we are gonna want to stop on time so that Ricardo can get his presentation started. So, ready, go.
Yeah, I will skip questions then. Let's get moving, I have some reference here. Because this talk is really about this last section, so I need to have time to talk about it. Which is new demands, new requirements that came up. Basically, Pulp services is just growing very fast, and they need something about these numbers of tasks per day while we were at this number. So a lot of work to do. And scaling horizontally means they will need connection pooling, which RDX proxy had some constraints about the Postgres usage, which we'll need to overcome. So Deco started with some great research on that, and he found that we just couldn't scale beyond certain number of workers because there was too much workers overhead on the database, like the CPU was going crazy. And also, I'll just share this graph. You can see a lot of PG advisor logs on the top queries here. So I would call that problem workers overhead. The other thing I mentioned is the connection pooling constraints. Postgres doesn't allow session-based advisor logs. I mean, maybe it allows, but the pooling won't work efficiently with that. There are some other stuff too, but I'll focus on this advisor logs constraint. So some of the changes about the workers overhead is this little randomization of acquiring a task. Let's say at this point in time, we have 3 unblocked tasks, which mean they can be picked by any worker. The workers fetch those 3 tasks. They may fetch roughly at the same time, and they will try to acquire them on the same order. So there is a high chance of a conflict because just one will be able to get it. Here it's wrong. I did 3, it's T2 here, but you get the idea. There is this weight of conflicts here. And what this little randomization does is that these tasks are unblocked, and it just reduces the chance of a conflict. It's worth mentioning that the order of unblocking still respects the order of when the tasks were dispatched. The randomization doesn't change that, which is something that Dennis pointed out. And it's a very important property of the system. We've added auxiliary workers because I've talked about some stuff that's not supervising tasks that talk to the database and consume resources. And if you have a lot of workers, you really don't need all of them doing all of the things. You can have a small percentage doing this janitorial stuff, like unblocking tasks, and it will serve the system, even at higher workers count. And the auxiliary workers only supervise tasks, so you scale just what you need. There is this wake up, unblock, handle, optimization. It's the same idea. The worker won't do stuff that we know it may not need to. Now about the RDX proxy problem, which is the problem of getting rid of advisory logs. First, we needed to rearrange this app status tables. We had different tables for each kind of component. But we wanted something like this, where a task has a field which points to any app, because any app can hold the log. So that was the first part. And the second part was to replace the advisor logs with a custom update query. So a worker would try to assign itself to the app lock, say it's using that. And another worker tries roughly at the same time to do it, but there's the row lock, so it will skip this update and then try to get the next one. Another scenario is that it will not be on the same time, but can be a little later. It will try to get it to assign itself to the task, but it's not empty, so it will also skip and try to get to the next one. So we've seen some requirements for the book installation, changes related to workers overhead, and changes related to the RDX proxy. And 25 minutes.
Outstanding, right on time. The only question I'm going to ask Pedro before we end the recording here is, do we have some results from the services load on the impact of these changes?
I'm a bit behind the formal results. Sorry.
It's okay. All right.
We had improvements, but I don't have like anything to show officially about it.
Maybe that's something you all can put up in discourse over the next week or two as you start getting actual numbers from these changes. All right.
Yeah.
I'm going to end the recording so that people have time to take a quick break and Ricardo has time to get set up. Why don't you do your final words here?
No, you can end with this slide.
All right. Thanks so much, Pedro. Let me end the recording here.